All right, we're recording. Hi, everyone. Welcome to this week's Lunch Talk. This week, our speaker is David Can, who is a professor of physics and engineering at Oregon State University. He's going to be walking us through the ins and outs of scientific writing and publishing based on his time as an editor for the Journal of Material Science. He's also my uncle, so I'm especially excited to have him here today. And with that, I'll pass it off to him to talk about the mechanics of scientific communications.
Great. Thank you, Jenna. Everybody hear me okay? We're good? Okay.
Yeah.
Just correction. So I'm a professor of material science and chemistry. I'm not a professor of physics. So
Neither one of those. Sorry.
Won't be taking any physics questions. So, but yeah, so the idea of this talk is really to kind of help you understand the system of publishing. You know, like any system, you kind of have to understand the inputs and outputs and the rules because it's a pretty important part of your graduate school career. And even as an undergraduate, it's kind of an important part of starting to learn the system so you can apply for graduate school. And so I kind of put this talk together because I think I'm in kind of a unique position to do so because I've been an author since 1993. I've been a reviewer since almost that long. I've been an editor for 15 years. So I've kind of seen the scientific communication process from kind of all three sides. The only side I haven't seen is from publisher, but I definitely work with publishers a lot. So I have a pretty good understanding of their view of things, and you'll kind of see that in this talk. And another part of that too is not just kind of the mechanics of writing, but also the content of papers and using data and presenting data. That's a really critical part of this as well. And so I think it's a really nice quote from Charles Babbage. It says, "Your errors using inadequate data are much less than those using no data at all." And so data is the really critical part. And a couple caveats. So I'm an experimentalist. So most of my stories and philosophies are based upon experiments and talking about experimental data. 90% of it transfers to those who do more computational work. You generate data in a similar way, just the flavor is a little different. So you have to kind of translate things to your world a little better. And the other thing that's important, especially now that we're recorded, is that so I am a paid employee for Springer Nature, which is the publisher of Journal of Material Science. So everything I'm presenting here is my opinion. It doesn't reflect in any way upon Springer Nature. And also in terms of just bias, so I'm obviously biased towards the kind of Springer Nature view of publishing. There are multiple publishers. Each of them kind of has different philosophies in the scientific publication process. And so I'm certainly biased in that regards by everything that I know and learn and the people I interact with in the Springer Nature side of things. So with that caveat, let's go ahead and get started. And so here's the motivation for this talk. I kind of outlined this before. So, publishing your work is really critical, and especially graduate students, your thesis work. It really provides external validation of the quality and impact of your work. So I have found over the years in advising graduate students as they go apply for jobs, I'm almost never asked my opinion on my graduate students. Almost never. And I think it's because it's a waste of time because we all love our graduate students, like our kids. And so basically they won't take our word for granted. What they will take is if the work derived from someone's thesis is published, that really means it's been externally validated. Someone who's not from your university has looked at it, checked the science, and found it to be valuable. And so that's a really important part. As an undergraduate, it's probably your GPA is probably the most important quantitative measure of how good your education was. At the graduate level, it really is those papers. That is the key part. And if you have a master's or PhD thesis without any external publications, it could be viewed as not being worth publishing. That the work you did, wasn't that useful. So the PhD itself or the master's degree itself isn't very valuable as a piece of paper. The value really comes from those research products. And so the thing I tell my graduate students is your job is not as a graduate student, your job is to build your CV, your curriculum vitae. And so, I show them an example of one and, try to think about all the different categories in there that, in the 5 or 6 years that you're there for a PhD, try to have as much stuff as possible that ends up on your CV. And when you come into work and the first minute, sit down at your desk, try to think about what you can do that helps end up as something which is on your CV. Papers is a critical part of that. That's probably the most important part of your CV is what papers you published as part of your work. But presentations, awards, scholarships, leadership roles, professional societies, internships, anything. And so I consider my job is to try and help them build that CV. And so I think that's a pretty good way to kind of look at your graduate school experience. Unfortunately, sometimes you have to tune the furnace or recalibrate the thermocouple. You have to do that. And that doesn't really show up on there, although there's a skills section. And so you could say, you know, how to, you know, program in Python or, you know, work in LabVIEW. You know, those things do end up there, but really try to think of that. So in that regard, to really think of this, publishing is a critical part of your role as a graduate student. So essentially, the three things I'm going to talk about. I'm going to talk about mechanics of publishing, you know, the system of publishing, how to truthfully depict scientific data, which is really the most important part of a paper. And the last part is very important. It's mechanics of using the work of others. And so we're talking about plagiarism, things like that. Sometimes it's obvious, sometimes it's not. So with publishing, so it's a business. And so like any business, it's useful to kind of see how it works. And you know, there are real costs. And so, you know, I think sometimes we forget, since Google is free, we assume Google has no employees because it's free to use everything. Well, of course it's not. They've got thousands and thousands of employees that all get paid salaries. And that's because there's money that goes into the system that makes, you know, Google Sheets or Google Docs makes that free for us. Similarly with publishing, sometimes you get an article that you could download for free and they go, wow, great, it's free. Well, there are costs behind that, and there are countless costs. Reviewers sometimes get paid, editors get paid, graphics people, copywriting, websites, copy editing. You know, there are thousands of people behind the scenes, real costs that are necessary for your article to end up, you know, on a website somewhere that is a published paper. So that has real costs. There has to be money in the system, right? Somebody has to put money in the system to allow that to happen. And so who are the people? Who are the agents? So it could be authors, could be readers, institutions, and advertisers, essentially the four possible places where that money can come from. So if we turn the clock back, you know, 30 something years, this is how almost all journals works. It's kind of the old traditional model. And some still do this way, where the author pays a price, the page charge, to publish the paper. And so that's essentially where the input for a lot of the dollars would go into. That kind of makes sense. The author has the most to gain by having this paper published, so why not give them the burden for paying for it? Then the journal goes through what it does and it publishes the paper. Then access to that paper comes either from a university, like George Mason, pays a reasonable fee to access that paper, or an individual can buy a paper, kind of like it is today, you know, 10 bucks, 20 bucks a paper kind of thing. So that worked out pretty well. But what changed is that, and another way this sometimes is a hybrid, a lot of journals are published through professional societies like the Institute of Physics or the American Physical Society. In that case, sometimes a society, since kind of publishing, you know, research is part of their goals, they can subsidize those costs. So maybe if you're a member of the American Physical Society, it might be free for you, might have that, those page charges might be higher if you're not a member. And then otherwise it's the same sort of thing, but maybe the articles could be free if you are members. You can kind of see all the articles in that journal. So an alternative model developed where then it essentially took away the fee for authors. So it was free to publish. Now, of course, money has to go in the system somehow, and the way it went is kind of the back way, and made universities and institutions pay much, much higher subscription fees to be able to essentially run the business of publishing those papers. And it was a, you know, many times, many X increase in costs that was brought on by institutions like George Mason and my university. And this sort of then unleashed the cable TV model of how this works, where just like with cable TV, there's really only 4 channels I want, but I can't get them. I need to buy 300, you know, 260 some that I'll never ever watch, but the cable company makes me buy those. Well, publishers did the same thing. You might just want Journal of Applied Physics or something like that, but we're going to make you buy the entire package with hundreds of journals with a huge fee because they can, because they have leverage. And that essentially caused, you know, a great increase in costs. And those costs, the burden of those costs primarily went to universities, and that was really difficult. And it made it very difficult. Now, why this model happened is, you know, it came down to the point where if I'm writing a paper, I got a choice. I can send it to an old journal where I have to pay, you know, $1,000 to publish a paper, or I can send it to a journal where it's free. Well, A lot of times when you publish a paper, the grant's ended, so there really isn't any money. You kind of have to scrape together funds from overhead or some other way. So, most of the time I'm going to choose the free one. That essentially meant this model really profligated at the expense of universities and institutions really suffering the consequences. And there was big money. This is, 4 years old, but Elsevier, which is kind of our biggest competitor, is one of the largest publishing firms in the world. And the profit margin on publishing was 36%, which is higher than any of the other main high-tech companies. So there's a lot of money to be had. And I think it's probably due to economics. They have leverage that they can apply in that regard. So something clearly had to change. And what really happened is, I think, kind of a movement in the public where, if you just think about it, it's kind of unfair that, we as taxpayers in the US pay money to support science. And then we can't access those results. That, Joe taxpayer would have to pay $40 to read a paper that kind of indirectly they paid for. And so this is, not so important in a lot of physics and material science and chemistry that I do, because I don't think the general public is that terribly interested in what we do. But in health studies, that's something where I think a very high fraction of, Joe or Mary taxpayer has a lot more interest in. And oftentimes, medical journals have a abstract, which is really for the general public. And sometimes they can't access that. So there's a real movement to kind of have publicly funded science be accessible to the public. And I think it's generally a really good idea. And the NIH a few years ago required that if you have NIH funding, the results of your research must be publicly accessible, which just makes sense, I think. And on top of that, now a lot of government agencies in the US and the EU are considering similar policies because it just kind of makes sense. Unfortunately, we still have the problem where money's got to go in the system somehow. Somebody's got to pay. So it's almost like it's gone back to the old model where the author now pays page charges again. That essentially allows that, for my article then will be free. So you might see, a Journal of Applied Physics has got 50 articles this month. 8 or 9 of them are free that anybody can access because those authors have paid a surcharge, usually $5,000 or so. It's not nothing. But if your grant requires it, you got to do it. And you can kind of put it in the budget. So when you actually get the research project, you put in the budget $5,000, for each paper that you think you're going to publish. It sort of kind of recoups those costs. So it just makes a lot of sense. Other journals sometimes use advertising as a way to do that. It's not as common, but I think it's another way to do that. And instrument manufacturers would love to be able to put an ad in your paper or maybe on the website where your paper is located. That kind of helps bring in costs as well. So I think there's definitely ways to do this. And there's this is the hybrid model where essentially you could either submit it for free and be behind a paywall, or you could pay that surcharge, $5,000, $10,000. That essentially allows your specific article to be open for free. Now, like anything that involves human beings, there's a scam to be had. And the scam model kind of generated just a few years after all this happened, where someone would create a website and create a journal with a prestigious sounding name. There's some examples down below there. So the American Journal of Advanced Scientific Research, or the Journal of Medical Research, or the American Journal of Material Science, which absolutely has nothing to do with the Journal of Material Science, which is my journal. So these are called predatory publishers. And there was a guy that actually started, cataloging these predatory publishers, and he actually got sued. So I think I don't think that web link works anymore. I think someone else archived it, for the public benefit, but he got sued a few times. So I think he no longer wants to be the person that publicly highlights these predatory journals. And what they do is they will, for a much smaller fee, instead of thousands of dollars like a real journal, for $50 or $75, they'll publish your paper on this website that sounds like a prestigious journal. So you can put on your CV, I published an article in the American Journal of Advanced Scientific Research, which won't fool you or me, but it could fool other people. If you're applying for a job, at a company or, I don't know, some government agency where they're not on top of things, you could rack up a huge CV by publishing crap and make it sound like it's great. So the publisher benefits because he or she gets $75 per article, and the author benefits because they get to say they published papers, but it's all bunk. It's completely nonsense. In fact, Here's one. So the International Journal of Advanced Computer Technology, which again sounds prestigious, sounds like a real journal, but it's not. It's created by some guy. And someone decided to submit an article to this journal. And you can see there, it's got some foul language, but the entire article is just formatted correctly, but the entire thing has "get me off your effing mailing list." 3 pages long, just has that sentence repeated over and over and over again. And for fun, he submitted that to that journal. And it turns out it got accepted. So he got an email that he was pleased to accept their article for publishing. Would you please just send us $150 to this Indian bank, and then they will right away publish this person's article. So, which is great. So it obviously tells you that it's complete nonsense. There's no peer review. There's no judgment of the science or anything. It really is just a way to make money. And so that's a neat way to show how this works. So what that means is you need to be a little careful. And so when you look at journals, you kind of make sure they're real. How do you know they're real? We can go look at that list to see if they're fake. Most of the time, they'll be with a real publisher like Springer Nature, like Elsevier, or have a professional society that backs it. That's kind of important part. So that's kind of the business model. And I'm going to stop right here, see if there's any questions. I know this is hard on Zoom. I'm going to at least try. So I just want to give us a chance. I also need a coffee break.
So it looks like one that was submitted before this, there's a couple about open access, and one of them is what is the benefit of paying for open access through the journal versus like having it publish the journal, but also posting on something like Archive or something like where it's.
So there's two things there. So the benefit of publishing open access is I have seen studies, and I don't have a reference for you right now, that show there really isn't much of an increase in citation of your work if it's open access. There's more downloads, but there's no more citation. As we'll talk about later on, downloads are virtually meaningless. Sometimes those are bots that are doing that. A citation is a more thoughtful, measurable quantity that someone has derived science from your work. And that's kind of the most important part, again, in your CV. Now, the second part is about archives. That's a good question. So, and the answer to that is there's certainly benefits to that. Check the rules on your publisher, because as we'll get in a little later on, there's copyright issues, there's plagiarism issues, there's self-plagiarism issues. It's very common. It's a really useful tool, but definitely check the policies of the journal before you do anything, because you don't want to kind of run afoul of the journal's policies. But it's definitely a very useful tool that people use. Any other questions?
I think the rest can wait until you get hit their topics later. At least for the submissions. I don't know if anyone has any here. All right, I think we're good.
Okay. I'll move on to the next part. So, so the question now is, so which journal should I publish in? And so, finding the journal that's the best fit is really important. So things you want to consider is the readership. Who are you writing to? Who's your audience? Who do you want to read the paper? Potential reviewers. Oftentimes, the readership is the reviewers, and we'll talk about that in a little bit. Think about, for your particular paper, what references are you citing? So if you're citing a lot of papers in one particular journal, that's probably the best fit for where you should submit to. And the last thing that I think you can't ignore is impact factor. I'll talk about impact factor in a little bit, because essentially some people will use that as a proxy for quality. And even though I don't think that's a good thing, some people will, so you kind of have to pay attention to it. So mechanics of publication. So publications are primary means of disseminating your work. And that's because in science, 99.99% of us aren't Newton, and we can't figure out stuff on our own. To solve a real, useful technological problem, it requires the ideas of multiple people. And we can't all be in the same room at the same time, especially nowadays. So essentially, journals and the scientific publication process is how we do that. That's how we allow multiple people with different technical backgrounds, different ideas to collaborate, through a timeline to solve a really difficult problem. Because again, one person can't know it all. So the peer review process is there to try to make sure that the article is sound, because since you're publishing an idea, you're publishing data, we want that to be as close to the truth as possible. We never reach, perfection, but ideally that peer review process is supposed to be a filter and to kind of improve and refine those ideas and improve the quality and the presentation of the data so that it can serve its purpose as being an idea that can be picked up, from time forward. So that's the goal of the process. So the whole thing I talked about money, that's different, right? That essentially just pays the bills. That keeps the lights on. This is the peer review process, which has a different goal. You can't ignore the money side of things, but that's essentially a parallel process. So essentially, if you do it, it's kind of hard to do a real flow chart because it's a kind of a complex process. But essentially, when you submit your article, if you decided which journal to go to, that's a good fit for you, and you think it would be a good viewer, a good readership, you submit it. First step is essentially with me, with the editor. And so essentially, I'm going to look at it, and there's essentially three options. So I can reject it outright, I can transfer it, or I can send it out for review. And so the things I'm looking at, A, is whether it fits our scope. And so every journal, if you kind of look under the homepage for a journal, there's a little link that says aims and scope. That's kind of a library science term that essentially defines what technical areas that this journal will publish in. And so I'll look at that. Format, sometimes, it's sort of silly, but, format's there for a reason, to make it easier to review and to make it easier to copy edit. So if people don't follow the format, if they're just slightly off, I'm okay with it. But if it's, dramatically off, then we'll send it back. I'll typically do a cursory review just to kind of look at it. And honestly, I flip to the abstract, the conclusions, I look at the data. And I can basically tell if it's a good paper or not from that. And then I can reject without review. And if the basically doesn't meet the technical quality that I assess at that stage. And whether or not that happens really depends upon the journal. Nature and Science reject probably 90-something% of the articles that are submitted at this stage. So they essentially just look at the impact of that paper, and there's certainly no regrets at all being rejected by Nature. It happens all the time. We reject about 50% without review, 50 to 60% without review, just because it clearly doesn't kind of meet the standards that we're aiming for. And sometimes instead of rejecting outright, we might transfer it to a lower ranked journal, so within our publishing family. And that is called cascading. So essentially, if you get rejected at this editorial stage, don't fret. It just means that there's another journal that might be a better fit for your paper. And so in our case, it'll either be a lower ranked paper or maybe one that's a better technical fit. So in our case, magnetism and glasses, amorphous materials, are kind of very niche materials that if they were in my journal, they kind of get lost. And instead, if we put it in a journal specifically focused on magnetism, it just gets a better visibility. And so it's just a better venue for it. So oftentimes, even though there's nothing wrong with the paper, I'll send it to that because it's just kind of, I think it's better off for the paper, for the authors, for the readership. And so you'll see that. Sometimes this happens too after you get a review. And so in that case, then it's your choice, but most of the time, the reviews will also transfer. So then the new editor of the new journal will get your paper, and then they'll get the reviews that were carried out at the previous journal. So they can kind of make an informed decision on what to do next. If I decide to send it out for peer reviews, I'll talk about who these people are in a second. We'll essentially go through, and the reviewers, they're primarily there for the technical soundness. So I don't want to publish something which is not technically sound. I only know so much, so I really have to rely on the reviewers to give that detailed analysis of whether or not those measurements are done correctly, whether or not the data is being represented faithfully. And so they essentially will, give me a recommendation on whether the article should be rejected or whether it should go back and be revised and sent back to the authors to fix some things. Typically, it takes 2 to 3 times. It's very rare that something gets accepted, at the beginning. It usually takes multiple rounds to kind of get to the right answer. And after that, then eventually gets accepted. So this is kind of what things look like on my screen. So this is my editor screen that essentially shows, I've got papers coming in. I've got some that have reviews complete. I aim for 3 reviews per paper, which means I probably get 2 good ones. Reviewing is a tough job and not everybody can hack it. And so if I aim for 3, I typically get 2 good reviews and 1 that's crappy. So essentially this process, it's kind of automated, so I can kind of queue up some reviewers. and I put some alternates. So if someone declines the invitation to review, it automatically promotes these. So essentially, it's a constant process of sort of setting up a queue of reviewers that kind of help give that technical feedback to me, so I know to make a informed decision. So, so anonymous peer review. So who are these real people? And so when you submit, for most journals, they'll actually ask you to suggest reviewers. And that's a really important thing. In fact, I even wrote an editorial on it a couple years ago on this concept of suggesting reviewers from your own work. So to me, this is a chance for you to basically find the 3 to 5 best people in the world that you think could provide input and improve your paper. And so I'm a real fan of transparency. And when I see a paper, when people have suggested 5 people that I know are really tough, very technical, and very rigorous, then I know that the author really wants to have a real review process. If you put down your friends or your classmates or your ultimate frisbee teammate, that sometimes we can tell it's not a scientist, sometimes we can't, but most of the time we can. That sort of tells me that you don't actually want your paper to go through rigorous peer review. You just want it published, and that looks pretty badly on the authors. So take some time to think about that, and really, and oftentimes you can look at the people you're citing. So look at the articles you're citing. Those would be great people to be reviewers because you're writing a paper derived on their work. And so it all makes sense that they could provide a lot of great input on your paper since they'll know the field very well. So definitely something to keep in mind. I think every editor does it differently. I use Web of Science primarily to find reviewers. So I basically try to find people who have published articles on the same thing that you're publishing on, because I figure they've got a current project, they're currently working on it, so they've got a really good insights into your work. And I think most editors do this. So see that second bullet there. Another reason why you should make sure that in your cited references, you've got to cite people that are also working on this problem because they will be their reviewer. Highly likely they'll be a reviewer. And if you have not cited their article that is related to what you're proposing, they're going to be kind of grumpy. And so you want to make sure you properly cite all your competitors, if you will. And so I typically get a mix of suggested reviewers and then I go find some. I definitely don't just use suggested reviewers. I kind of make a mix of things to make sure we've got a good balanced view of things. Yeah, on the last bullet there. So sometimes I'll also look at the references that you cited and I'll go pick reviewers from that list too. So that's essentially where they typically come from. Now, there are some concepts. So we talked about open publishing in the business model of things. Well, there's also some emerging concepts in the peer review process, because it certainly is imperfect. The way I look at it, the peer review process helps science, asymptotically approach the truth. It never really gets there, but it constantly, with each peer review, with each paper, we get closer and closer to the truth if it's done correctly. And so the current process that most journals use now is what we call single blind, where the author does not know the identity of the reviewers, but everything else is known. So the reviewers know who the author is, and I as editor see everybody's affiliation. So there's just one blind there. And having that blind is important because then the reviewers can be frank in their review of the technical parts of the paper. And so that's pretty important. There's new journals that are starting to look at double blind, and we're actually working on an editorial right now on this process and kind of weighing the pros and cons. In this case, the reviewer would not know the identity of the author. So I, as editor, would get the paper, then I would strip the affiliation from the authors and send it to the reviewer. So the reviewer would not know who the authors are. And there's a triple blind process that requires a little more manpower, where essentially I, as editor, would not know who the authors or the reviewers are. There'd be a different editor that would essentially set up the peer review process, and then all I would get is a paper with no authors and reviews with no names. And essentially it judged things on that. Now, why are we doing all this? Well, it's because of bias. And so there's definitely lots of documented, and data showing the influence of bias. Bias against women authors, bias against countries, many, many ways that essentially, we're human beings, we're flawed, and our biases infect everything, including the peer review process. And so by using these, double blind or single blind or triple blind processes, that helps minimize bias. And so it's hard to know exactly where this is going to go, but I think it's definitely something that's kind of in the works, and things may change in a few years. Now, as one thing I mentioned is that as part of this process, unfortunately, I am not blinded, and so all of the authors know who I am. And at our journal, we reject about 85% of all papers. So that's not a great way to make friends. And so sometimes one time I got feedback. Well, actually, often I get feedback from authors where they complain, and tell me I'm an idiot. One person went to the extent of actually sending me this in the mail, which is kind of a nice, recognition of my job as editor. It's poop in the mail, which is pretty impressive. And so some people get a plaque, some people get, an award for doing their job. I got poop in the mail. So that's kind of cool. I think it's just part of the job of not having many friends as an editor. Thankfully, I get paid. All right. So other things that you keep in mind is not all papers are the same. So definitely kind of keep that in mind. Letters tend to have less prestige than articles. The most prestige is review articles. And that's something I would definitely have you keep in mind, especially PhD students, especially think of your literature review, your chapter 1, whatever it is. That could really be easily turned into a review article. And review articles are highly downloaded, highly cited, and gives you a lot of visibility. And so it's hard because, at the end of your thesis, you're exhausted, and it's hard to kind of spend the extra effort to take that chapter 1 and turn it into a review article. But it really is a great way to kind of maximize your visibility as a researcher. And again, that's on your CV. That looks great if you have a review article. Are some caveats. There are some letters-only journals that are actually highly prestigious. So physical review letters is one of the best. But generally speaking, letters sometimes, since they're shorter, have a lower ranking. Then abstracts, proceedings, and then journal articles. Or journal articles are generally the most valued in terms of how people look at your publication record. And generally speaking, it's both quantity and quality. So it's having a small number of papers is okay, but they better be really good. It's best to have quantity and quality. That's essentially how we do it. I've published 130 papers. Half of them aren't that great. They served a purpose. They had some data that was useful. The other half are pretty good, and that's kind of how you got to look at things. Sometimes you don't know it's good till later. Sometimes you publish it, and it turns out actually that was pretty good. You just didn't realize. So let's think about these ways to kind of judge papers. And so there's ways we essentially use things to kind of rank the quality of journals. And so this is Oregon State's interface. George Mason must have another one in terms of how you use databases to kind of look at journals and look at papers. And so the way we kind of quantify things. So Web of Science and Google Scholar. I'm a big fan of Web of Science. It is put together and organized and run by library scientists. Google Scholar is done by computer scientists. There's no thought, if it's on the web, it's on Google Scholar. Web of Science, there's actually a person that purposely curates what can and can't go in Web of Science. And so you may or may not agree with that person's curation strategy or values or ideals, but it's definitely a thoughtful thing. And I've met the Clarivate people, and they're really good people. So I'm a big fan of Web of Science. It's harder to use, it's a pain compared to Google Scholar, but I think it's worth the effort. So everything I'm showing you is what Web of Science looks like. So how do you find articles? So this is a regular old search engine. It's not too different than Google Scholar. But if you use the journal citation reports, this helps tell you something about the journals itself. And so if you kind of use it and follow through, you can find a specific journal. And this is now for looking at, this is for physics, it tends to matter, one of the categories. So there is something here called a journal impact factor. And so this is something that is used as a proxy for quality. And what it really is, it's kind of like a citation rate. It essentially is, on average, how often an article in that journal gets cited. It's not exactly that, but you see the formula here. So essentially in the numerator, it's for all articles published in 2016, the number of times articles published in 2014 and 15 were cited. So essentially you look at 2016, you look back 2 years and count all the citations for that particular journal. And then the denominator is the number of articles published in those 2 years. So it's not exactly citation rate, but it's like that. The higher the number, the better. So you see Nature Materials has an impact factor of 38.8. So essentially that means on average, those articles get published about 40 times in a year. which means it's pretty impressive. So that means that article published in that journal generated 39 more ideas. And so that essentially means this journal has a big impact in the field. Now, this was created years ago. Actually, remember the business model I talked about where the prices started going up for libraries to buy journals? This was used as a guide for librarians to figure out which journals to pay for, if they're strapped for cash, because the ones that have the highest impact factor are probably the ones that are most valuable to researchers at your institution. Now, unfortunately, it doesn't get used that way. It now gets used as a proxy for prestige and quality. And it definitely has some value in that regard, but it gets exploited. We'll talk about that in a second. So here's if you kind of look at different rankings, there's all kinds of ways. There's median index, there's eigenfactors, all kinds of different ways, half-lives. It gets, this is data. So library scientists will go to town and find ways to quantify things. But generally speaking, the higher the impact factor, the more prestigious the journal is, or at least many people will think so. So it's not a terrible idea for you to think of that when you try to figure out which journal you want to publish in. Even though, it's a flawed metric, other people use it. And so if you publish a paper in the journal at the top of that list, Nature Materials, people will say, wow, they have a paper in Nature Materials. That's great. And so, knowing the audience on who's reading your CV is kind of an important aspect of things. Why does it matter? Well, I've been an admin a lot over my academic career, and it's always easier for humans to use quantitative measures than qualitative measures. So if I've got your CV, I'm comparing two CVs, I can say, well, this person's published in higher impact factor journals than this person, so they must be a better researcher. We know that's not true, but it's a number, and you got to use something. What am I going to do? Read the articles and then on my own assess which paper is better, which publication is better? Yeah, you should do that, but it takes a lot more time. It's easier to say, well, that one's got an impact factor of 12. That person's published in a journal impact factor 2. This one must be better. So people think that way. So keep that in mind when you build your CV. That's an important thing. And the other thing that's important is that most journals, including my own, strive to increase their impact factor because, in some cases, people only really count articles in high impact factor journals. So with universities and institutes for rankings, papers published in that top quartile are the ones that are most influential in rankings. In fact, in the United Kingdom, it's a big deal where to stay in the top research tier, you have to have so many papers published in the top quartile of your field. Same thing with China. China, essentially for promotion, if you publish a paper which is not in the top quartile, I don't think it counts at all for your tenure or promotion. Research or promotion. So in some cases, those papers help you with your own promotion. If you're trying to get tenure or trying to get a job, trying to get a postdoc position. And as I mentioned, library collections. So they want to, if they got limited funds, they want to make sure that they support the researchers on campus, and impact factors often used in this regard. So you really have to kind of keep that in mind. So if that's the case, if impact factor, as flawed as it is important to some people, you got to think about that. So when you write your manuscript, remember that people are going to be looking at the impact factor of your journal. The editor is going to be looking at how your paper will contribute to that journal's impact factor. So think of that formula. It's citations, right? So you want to write an article that will get cited heavily. So it wants to be, good science, popular science, not popular, current, I can't think of the word right now, but something people will care about, right? Have an impact today. And the other thing is you want to make sure that your article cites recent articles in that journal. And so you can think of it as kind of gaming the system where you're just going down, articles from that journal. And so, for example, if I want to submit to Journal of Applied Physics, if I had, dozens of citations to recent Journal of Applied Physics articles, if my article gets published, that will help the Journal of Applied Physics impact factor. So you could game it and just put out 100 articles of recent articles. That would greatly impact their impact factor. But that's obviously transparently unethical and unprofessional. And every journal editor will see that. So don't do that. But do think of an article, remember I talked about the whole idea of publishing is to start, connect ideas. And it's really kind of like a conversation. You are publishing an idea and some concepts. So you want to have, just like making a conversation, you want to kind of bring in relevant context. Look at that journal's recent articles on that topic or near that topic, and really show the context of how your work contributes or compares or contrasts to recent articles in that journal. So that's not gaming the system, that's helping build context and kind of starting a conversation about the thing you're publishing on in that journal. And so that's kind of the best way to do this, is to really think about impact factor when you do everything, because people will use this as a metric. Now, the problem is this then motivates bad behavior. Again, we're talking about people. And so a reviewer might ask you to add references to their recent articles because they want their papers to get cited. An editor, this would be unprofessional, but it happens, an editor might ask you to add references to recent articles in that journal because that will help their impact factor. And authors might add tons of citations to their own papers. It's called self-citation because that adds their own H index. So what's an H index? So an H index is the way we rank people. So we got to rank everything, we got to quantify everything. We can even rank people. So if we do that, we can put in our name. So I can now, instead of searching for a paper, we can search for a human being. So this is me here. These are the 3 universities I've published papers at. I can bring up all my papers. And essentially then you hit something called, so a particular paper, it shows you how it's cited. So that paper has been cited 58 times, which is pretty great. But then you can also hit a citation report. So that essentially takes all my papers and then generates a citation report. And I get something which kind of looks like, you guys seen that movie Moneyball? It's got all the statistics of sports. It kind of shows all my stats, how many doubles and triples and home runs. This essentially shows how many times I've been cited per year. You can actually see COVID in there, right? COVID kind of hit 2019-20. And the most important thing in here, well, at least for many people, is this concept of H index. So that comes from data science. So H index, actually, I've forgotten which H stands for. But essentially, that means that on average, I have 28 papers that have been cited 28 or more times. So the higher your H index, the more influential you have been as a researcher. Some of the times it kind of also pulls out self-citations. So if I cite myself, Web of Science helps you take that out because that's kind of false or fake. You should certainly do it because if you're, following up on previous work, it's perfectly fine to cite your own work. That doesn't count quite the same as a real citation from some other author. So you can kind of go through all this, and then this essentially is shows the papers and how many times have been published. And then here's the kind of the list of the Hall of Fame of H index. So Sigmund Freud, his H index is 266. So I don't know much about psychology, but that must mean he wrote at least 266 articles that were cited 266 or more times. And he has almost 500,000 citations. And I actually generated this list a little while ago. Oh, wow, look at that. I didn't notice that. Number 20, A.S. Fauci. I wonder if that's Anthony Fauci. Wow, that's pretty cool. So his H index 194. It's pretty impressive. And again, this is a couple years old. So there's definitely a lot of famous names on this list that kind of really show how important it is. But again, this kind of motivates bad behavior. So again, people want to boost their own profiles, and you can do that artificially. And so oftentimes, not oftentimes, 1 out of 20 times I get a reviewer that reviews an article for me and then adds a statement, but the author really should cite these 7 articles that are the reviewer's articles. So he or she's trying to boost their own H index because it might help them in their promotion or something else. And lots of ways that essentially, human beings do this. So I call this the other H index, the hyperbole index, where people kind of oversell things and kind of greatly look at the impact of things. So I think it's important to realize that, a lot of science, a lot of research is done under stress. Graduate students trying to get a PhD, trying to get a job, faculty members trying to get tenure, universities, departments trying to get ranked. So all those pressures and stresses motivate bad behavior. And so unfortunately, kind of have to keep this in mind. One doesn't affect you as much as me as editor, but essentially it kind of does show the downside of things. Now, one important thing to point out is just because something is cited a lot doesn't mean it's actually the best or a good article. And my most cited article, and this was a couple of years ago, that actually published when I was a graduate student, has been cited, I think now 200 something times. I meet people that at conference go, oh, David Cann. Oh, you're David Cann from Cann, Randall, and Trout. I go, yeah, that's me. It's a paper on a particular material that we use in cell phones. And the problem is that this paper has a fundamentally flaw. So like I say, it's a highly cited paper is not necessarily the best. It just means it's essentially the first. That's all it means. And so an example here is that one's been cited in this. I'm a material scientist, so I completely got the chemistry wrong. So in my paper, I published that the stoichiometry of the compound was what's shown on the left. That's completely and abjectly wrong. Just 2 years later, someone corrected it and published the correct stoichiometry shown on the right. So that correct stoichiometry was published in 1998. So 23 years later, I still get citations on something which is completely wrong. And so it's definitely, don't just follow citations. It really means you got to be more careful about it. And there's lots of examples of where this is the case. And there's we're a little low on time here, so I won't belabor this. But even the discovery of high temperature superconductors, YBCO, yttrium barium copper oxide, was wrong. It was actually ytterbium barium oxide. The first publication of that was ytterbium barium copper oxide, what we know, which is not superconducting. It's a very boring semiconductor. Yttrium barium copper oxide is the correct stoichiometry. So it's definitely something that pervades a lot. All right, so two other things I want to talk about is how do we depict data and how do we use others in the time that we have left here. So with publishing things, the ideal is to make everything perfect. Try to make sure every conclusion is supported, make sure it's reproducible. Of course, you only got so many years working on a PhD, so you can't be absolutely certain it's reproducible. You have to kind of draw the line somewhere. But remember, that paper will last forever. Like my paper that's got something wrong that now forever people keep citing something which is completely wrong. My name's on it. Take care in citing others. So remember, these people might be your reviewers. So it's better to have too many references than too few. And so, the number of references really kind of depends upon things. Think about, that data in particular is really important. So that's kind of the most important contribution to the literature. So make sure you carefully and in a detailed way present what that data is. And in the old days where we had paper limits and page limits, it was kind of difficult. Now that most publishing is online, we have supplemental material that you can add. So make sure you contain all the information necessary to reproduce that data point. And if it's too long or too laborious, put the boring stuff in supplemental information. If you don't want to detract the reader from the real results. But you want to make sure people can reproduce that. It's really important. And it really comes down to, what do you do with, flawed data? So here's a good example. You've got some controlled variable and you have some measured variable, and you're expecting it to be along that line. And darn it all, you get that one point right there that just doesn't make sense at all. And assume, everything's taken the same conditions. So for some reason, you had some crazy data point there. So let's think about what our options are. A, you can leave it as is, like a big wart on your figure. You can take it out but not mention the text, or you can take it out with no mention of the text. Well, the best course of action is really A, leave it there as is, and just provide context. B is completely unethical. You can't do that because that's essentially your, not giving testament to reality. You have to, as a scientist, it's part of our job. It's our ethics, our professional standard of conduct is to faithfully explain what happened when we do our experiments. And the last one is take it out. C is wrong. So B, take it out, but mention the text. So essentially explain what happened and why you modified the data. And that's pretty rare where you can do that. So A is the best course of action. B, and I'll talk about a specific example where you can do B. C is essentially never. So one of the reasons is maybe something really cool happens that you didn't know about. So if you hadn't published that data or given testament to that data, you might miss something really interesting that happens. In an ideal world, you could do 10 more experiments and see if this thing happens. But because of budgets and times and experimental conditions, you may not be able to. But by publishing that crazy data point, someone else might have another idea, years from now, maybe 20 years from now, that data point helps them, construct a theory or an explanation. So, it's always best to be honest and truthful and publish it with I love seeing noise in data because that means it's real. So don't be ashamed at all to show noisy data. It's wonderful. And explain what the noise is, why it's there. That's the best case scenario. So here's some examples. This is one of those I don't know what the hell happened. So put a circle and right on the figure, I can say that was anomalous grain growth. I don't know why that happened. And so sometimes I do it in the text and explain there's a data point there, who knows what the hell happened. Be as honest and transparent as possible. As think about it as a reader, you love that because you read, go, what the hell happened there? Well, in the author states, in the text, this is what happened. I don't know. That's perfectly fine. You can't explain everything. This is science. Most of the time you're doing something no one's ever done before. So, might as well be as honest as possible. So here's an example where, as a last resort, you can manipulate the data. And so this is an example of X-ray diffraction. And so X-ray diffraction works best when we have a single wavelength. And then Bragg's law basically tells us where those peaks align. But every once in a while, we get a parasitic peak that comes in. And one of them, for reasons I won't explain,
Dave,
coming
you
from a different
froze.
wavelength from a tungsten impurity. What happens is we get a set of parallel peaks that comes from that second wavelength. We know exactly where they come from. And so in that case, we can kind of eliminate that data and we can strip it. We just have to be honest about that. What happens if we don't do that? Well, you can go to jail. So scientific fraud is real fraud, and people do and can go to jail for not following that. Last thing, in just a few minutes here, I want to wrap up, is how do we use other people's data? And this is an unimportant part about plagiarism. So it's certainly necessary and proper to use the results of other people's work in your own publications, but it's important to do it properly. Again, think about a paper is a conversation, it's an idea. So it's important to connect that to all other ideas. And so you want to use other people's ideas to kind of provide that context. So when you use text directly from another author, never. You can use it sometimes with quotes. So if you're going to use, some description from another author, you can do that, but it has to be in quotes, and you directly have to then cite it. Instead, generally, you want to reference their ideas and rewrite them in your own and then cite it. And of course, it's now very easy to catch plagiarism. So every time I get a paper, it runs through a filter. And here's the case where someone has gone through and just basically, I call this a medley. They've taken 7 or 8 different papers and they've used a medley of their sentences to kind of make their own. What about your own work? This is another important aspect. You can use your own if it's from the same publisher. If it's from a different publisher, then it's a copyright problem. That publisher owns the physical manifestation of work. So if you were to reproduce that text, you're violating copyright. You can get permission if you want, but the best thing to do is just rewrite it. Take 20 minutes and rewrite that sentence or rewrite that paragraph. If it's from the same publisher, you can reuse the same text, but it kind of looks sloppy. So someone might be reading 1 or 2 of your papers and they're going to recognize the same paragraph. So just rewrite it. It just looks much better. There's nothing kind of gives the impression that they're not very unique. Same thing applies to figures. So figures and data. So cite things, be very careful, make it very clear what's your work, what's other people's work. So I like to put in this table this work and then make it very clear who other people's work is. And same thing with figures. You can use other figures, but you need to get copyright permission. That's very easy nowadays. You can go straight to the publisher and they've got a very simple web form that allows you to gain permission to use their figure. It looks great. And so I definitely recommend you do that. And again, those people might be your reviewers. So if they see you use their figure, they might go, oh, that's nice. That's my figure. And they probably cited it. So that's definitely a good thing to keep in mind. What about using your own work? Well, in that case, then it's the same thing. It's a copyright problem. If it's from the same journal, then you can reuse it. But again, just spend some time and kind of recycle it. And so I do this all the time. So the figure on the upper right, that's the delphosite crystal structure. Then in a different journal, I just rotated it, changed colors. Voila. It's essentially like art. So the copyright is for the actual physical manifestation of that figure. If you make any changes, any significant changes, then it's fresh, it's new. So I just rotate, change colors, whammo, new diagram. And of course, attributing things is very important with all data. So I kind of reproduce things, always make sure those people are going to be your reviewers. And what's at stake here? Well, again, if they find plagiarism or find errors or citation errors, that gets written up and that shows up, in journals. It's there forever, again, with your name on it. So it's something that you don't want. So conclusions. Remember, your published work lasts forever. So there's not enough time for you to make everything perfect. That's kind of an unfair goal, but try to make it as best as you can. Know your reviewers, know your audience, know the system. Keep your co-authors fully informed because their name is on that paper too. So make sure they are aware of what's in it and make sure they're active participants in the process. And then try to be an active participant in the process yourself. So, ask your advisor if you can help review papers. I certainly have my graduate students do that, because the more you can kind of see this process from different sides, the more effective you can be in publishing your own work. Okay, hopefully I've had some useful information for you, and I would be very happy to answer any questions you might have.
Okay, so we have one in the chat that was submitted. Can you talk about what is a good use of ResearchGate?
Oh, yeah. So, yeah, that's a good question. So I don't use ResearchGate. I'm probably the worst person to ask the question. Uh, so I use Google Scholar as my research webpage, because it kind of curates itself. As I add more papers, it automatically shows up on Google Scholar. The thing I don't like about ResearchGate is it requires you have to register. You know what I mean? And because if I go to someone else's ResearchGate, I don't have a ResearchGate account because I don't like that stuff, and I can't see everything. So yeah, I'm probably. I also don't do Facebook. I don't do LinkedIn. So I'm probably, the dinosaur's point of view is probably not that useful. So and honestly, I'm not sure ResearchGate is growing. I think it's kind of hit its limit from what I kind of gather from just editors' meetings.
Okay, and then we've also got Rex. We talk about the referees and how you pick referees. There's kind of an urban ledger, and it looks like where how you also can submit referees that you don't want and who shouldn't be reviewing your paper.
Yep.
Basically, this person has heard that when you submit names for ones that shouldn't, they might also pick one of those as well as the ones that you do recommend. Is that true? And I guess how do you avoid getting a referee from a competing group?
Yeah. So I would be very. Okay. So it's rare that I get reviewers that should not be selected, that the authors have a list of people to not contact. Pretty rare for me. That's probably pretty discipline specific. Um, I would honor that personally, but I guess it is up to the editor. I would probably make sure you have a reason in there that you can, a terse 2-3 sentence reason why you don't want those people to review their papers. Um, yeah, I have not encountered that, so I don't really have a intelligent thing to say about that. Yeah, that's again, human behavior, unfortunately, comes to the forefront, and yeah, it's a shame.
And I have a question also based on so I know Alex had submitted to a journal that it's in Europe, and basically when they publish the paper, they also publish the referee reports. Basically, it's kind of all super transparent. I know I've heard of also some, I think in the US, I can't think of which ones they are, where they have kind of like a message board feature. Basically, everything is kind of public. Have you been seeing any kind of trends of going towards that?
Yeah.
Pros, cons?
So Nature has a new initiative in that called Frontiers, which is supposed to be, an idea where, you publish the reviews, and you call the reviewers review editors. And so the idea here is that they can gain credit for reviewing papers, which is kind of good because it's kind of a thankless task, reviewing papers. And by putting their names down on the paper, it gives them credit and also gives them transparency. Now, the problem with that is that it's harder to be frank in assessing someone's work if my name's going to be on it. Especially if it's a problem. Bad feelings could derive from that, and I think there's benefits to the anonymity in the review process. That said, there's benefits to transparency, and especially the idea of allowing comments on an article post-publication, so that people can ask questions of the authors, and other people can chime in, say, I did a similar measurement, this is what I got. So it kind of really helps build that conversation. So there's a lot of benefits to that. Yeah, it's a hard thing. And that becomes almost like a continual publication. So a publication doesn't stop when the paper gets published. You can continue to add to it, and yeah, I get confused by that because there are some legal parts to publication that you can't get around with intellectual property. So when a paper gets published, that date at which it was submitted, that is the date of the invention, if there's ever any patent that gets associated with that. Once you start putting it into these other formats, that could get things a little more murky. So I don't know what I think about that. Yeah.
And it looks like the last one that we have submitted through the form is how can you make sure that a faculty member you're looking at for an advisor is active in publishing papers and providing opportunities for their grad students?
That's a good question. So the best way to do it, I think, is Google Scholar or Web of Science. You can actually look up the person's name, and you can see what recent papers they published. And I'd recommend go ahead and reading it. That's probably a pretty good assessment of what you would do as a graduate student in their group. And so if you like the content of the paper, you like the subjects and the experiments, that's probably a pretty good aspect. It's also a great way to try to get a position in their research group, because you've read their papers and you contact them and say, I've read your paper on X. That's a great way to start a conversation with a potential advisor, because then you can really express your interest, and they'll have a good idea of your interest in the topic. The other thing that is not a bad idea is to the oftentimes email addresses are listed on the authors, so you can email them. You can email the graduate student. I usually make my graduate students the corresponding authors, so you can email them and ask them about the work, ask them what they liked, what they didn't like. This is your life, so I think getting as much information as possible is the best way to go. So try to get as much information so you make a good decision on what is a good advisor for you. I thought that's a good question.
All right, thank you so much. So that is the end of the questions that we have submitted. Any last minute questions from somebody in the audience, whether through the chat or you can just unmute yourself? Nope. All right, well, thank you very much for coming and for talking to us. I will go ahead and stop the recording if I can remember how to do that.